and welcome back to Building AI Agent Products webinar series, a four-part series where we move beyond the foundational concepts of AI agents to learn how to implement them successfully in your products. This is the second part of the series, going from opportunity to product design. I'm Elio Damaggio, PhD, and currently head of product at Amazon. Let's get started. First, if you watched the previous webinar, welcome back. In that previous webinar, we described the systematic framework to identify AI agent opportunities, evaluate them across the three strategic pillars: computational architecture, reasoning complexity, and autonomy design. We'll learn how to audit workflows to find processes that are agent-ready and build compelling business cases. Today, we're going to take these identified opportunities and transform them into concrete design specifications that will guide your development teams towards successful implementations. This transition from identifying an opportunity to the design is critical, and many AI agent initiatives fail exactly at this point. Teams often default to familiar interaction patterns, typically chat interfaces, without really considering if these patterns are really adapted and appropriate for the user needs or leverage the unique capabilities of AI agents. In today's session, we will think beyond the conventional interface of like chat or GUI and design human-agent collaborations that build trust progressively, that handle errors gracefully, and create sustainable competitive advantages. We'll also look at how a multimodal AI and edge processing really change what's possible in interface design and how your autonomy design decisions become core to how you think about your product instead of simply an implementation detail. Before we get to that, though, let me tell you a little bit about me. My name is Elio Damaggio, and I've been building products in cloud, IoT, data, and AI for the last 15 years, all of them in Microsoft and AWS, where I'm currently head of product in the agentic code transformation space. I have a strong tech background. I hold a PhD in computer science and a past life as a software developer. I authored a few patents and an RFC standard for the web push protocol. So if you're receiving notifications in your browser, it's a little bit of my fault as well. You can reach me through my LinkedIn page as reported on the slide. And also, I have to say that this presentation only reports my opinions and is not related to my current or former employers. I want you to design human-agent collaborations that go beyond choosing between chat and graphical interfaces. You want to create a specialized interaction pattern that aligns to the requirements of the agent-based workflow that you identified. We want you to be able to design trust-building mechanisms that help users develop confidence in agent capabilities over time. And also, we want you to be able to architect error-handling systems that maintain user confidence even when agents encounter their limitations. This is usually done through natural escalation pathways that are seamless to the users. More importantly, you learn to think about design autonomy as a fundamental philosophy that shapes every aspect of your user experience. We'll look how multimodal capabilities, they're not just adding voice or image input, but also how you really have to rethink how humans and agents share information and coordinate actions. You will develop the ability to design de-escalation pathways that feel natural instead of disruptive, because they're actually part of your workflow. And very importantly, to create feedback loops that enable continuous improvement. This is fundamental to integrate the agent capabilities into the existing workflows without forcing the user to completely change their established pattern. This is not about making AI agents that feel humans or change or look like a colleague. It's about creating a collaboration that really empowers the users in a way to feel natural. One of the most important mindset shift that has to happen is to really go from thinking of agents as tools, but as collaborators. Of course, not human collaborators, but collaborators nonetheless. In traditional softwares, we always think in terms of the deterministic outcomes. So a user clicks a button, fills a form, and you get a predictable output. In agent design, instead, we have to think in terms of delegations, supervision, and coordination of these agents because they are collaborators. Let's look at a difference. In a search tool, you put something in a text box, you have you get provided with a results list, and then you have to synthesize that results list to get to your final objective. In a research agent interaction, you want to provide a higher level objective to the agent, which allows the agent to perform autonomous exploration and returning with conclusions plus the reasoning. Of course, you need to balance and do some trade-offs. There are three fundamental tensions: user control versus agent autonomy. How much does the user get to decide what the agent does versus how much autonomy the agent has to execute to reach its own objective. Transparency versus simplicity. How much visibility does a user have into the inner working of an agent versus just speaking of at a higher level and at the goal level. And finally, power versus predictability. The more an agent can do, the less predictable its output is going to be because the more unknowns it will have to take care of. While chat interfaces are basically the default for many AI applications, they often fail to leverage all the capabilities of AI agents. And in doing so, they actually fail to meet the needs of the workflows that they're meant to execute. To design effective agents, we need to match the interaction patterns to the specific type of collaboration that is needed by your workflow. Let's look at the three most common collaboration patterns. The dashboard controller pattern works well when agents operate continuously in the background, where the users only need to know what's going on at any given time and perform interventions selectively. Imagine a supply chain agent that continuously monitors inventory levels, supplier performance, and demand patterns. Rather than requiring users to ask questions, the interface proactively surfaces insights, anomalies, and recommendations, however, providing drill-down capabilities for investigation and override controls. The delegation workspace pattern is instead better suited for scenarios where a user assign a complex task to agents and monitor the progress over time. Think of a content creation agent where users can queue multiple articles and see the agent's research project progress, review the graphs at various stages, and provide feedback so to shape and steer the final output. Finally, the augmented canvas pattern embeds the agent capabilities directly into the creative or analytical tools. Like a design agent that suggests improvements while users work in their familiar design environment. Each pattern creates a different collaboration dynamics and serves very different user needs. The successful integration of AI agents in the user's workflows depends on trust. But trust is not granted. It's earned through consistent demonstration of competence and reliability. To this end, we need a systematic approach to build this confidence rather than asking users to immediately trust agents with critical decisions. We want to start with low risk, high visibility tasks and gradually expand agent responsibilities as trust develops. This is not just risk management. You want a positive reinforcement cycles that accelerate adoptions in order to maximize long-term value. You can start implementations with the agent operating in shadow mode, performing tasks alongside humans without affecting the actual outcomes. User can then see what the agent would have done and compare it to their own decisions. This builds confidence when they align and they understand the differences when they diverge. Next comes the suggestion phase, where the agent provides recommendations that the user can accept, modify, or reject, with the agent learning from these interactions. Then, in the supervised autonomy phase, you can allow the agents to act independently for routine cases while escalating edge cases for human review. Finally, full autonomy emerges in only for well-understood tasks, where the agent has demonstrated consistent success and for which risk assessment has already been performed. Remember that this progression is not linear or uniform. Different aspects of the agent's responsibility can progress at different rates based on competence and user comfort levels. This is what will also change the interaction pattern that we were seeing before. Often, how your agent handles errors and limitations is even more important than how it handles success. Users can forgive mistakes if they understand them, can recover from them, and trust that the system will learn. To handle errors effectively, you need to go beyond simple error messages. You need to create a strategy to detect, communicate, recover, and improve. It is critical throughout this process to maintain user confidence. The first principle is to express confidence level. Agents should express the confidence level in their actions and recommendation. This is to allow users to apply appropriate scrutiny when there are decisions that are low confidence. Also, when agents encounter situations that are beyond their capabilities, which happens often with current foundation models, they should recognize these limitations proactively rather than attempting to just try it out. The escalation should feel collaborative rather than like failure. With the agent providing context about what had happened, why is it struggling, and what human input would be most helpful. Finally, recovery mechanisms have to be robust and accessible. They have to allow you to roll back agent actions, modify agent decisions after the fact, and provide corrective feedback that prevents similar errors in the future. Clearly, from this from the discussion about recovery, this influences how you design your whole interaction and which part of the workflow you actually can execute with agents. Most importantly, errors should become learning opportunities. There has to be continual learning from the agent. For every error, the agent should basically try to understand what went wrong and basically remember how to improve in the future. This can be both automatic or happen with human in the loop. And poor design can destroy trust and create frustration instead of actually strengthen the partnership. Effective escalation is not about admitting failure. It's about recognizing that the agent needs human judgment, creativity, or authority. And you have to facilitate smooth transitions that maintain the momentum and context. The best escalation pathways feel like natural collaboration rather than system breakdowns. Think of escalations as driven by triggers on confidence thresholds, capability boundaries when the agent is not able to perform certain things, or authority limits. They're not just error conditions. When escalation occurs, The agent should provide rich context about what it's trying to accomplish, what it has learned so far, what specific challenges it has encountered, and what type of human input would be the most valuable. This context transfer is crucial for efficient handoffs. Consider also creating a stage escalation where the agent first seeks clarification or additional parameters before fully handing off the tasks. The interface should make it easy for humans to provide targeted guidance that helps the agent continue rather than just taking over completely. After human intervention, the agent should be able to resume operation with new knowledge. You really want to create a learning loop that reduces further future escalations. Remember that escalation pathways are also a natural breakpoint for human review and quality assurance. So instead of creating a potential source of frustration, create a point of oversight, an opportunity for oversight for the users. To enable effective collaborations, transparency and explainability are critical. This is not about showing users every detail of the agent's processing. It's about providing the right level of insight at the right time to build trust. The challenge is to provide enough data without overwhelming users. The agent has to adapt the explanation to user needs and context. So how do you design smart explanations? You want to implement a progressive disclosure system where basic explanations are immediately available with detailed reasoning accessible on demand. You want to design visual reasoning traces that show the agent's thought process through connected steps rather than just a wall of text from like a reasoning model, for instance. You want to create counterfactual interfaces that can show how different inputs or parameters would change agent decisions. This helps users understand the sensitivity and robustness. You want to develop confidence visualization that intuitively communicate uncertainty without relying on statistical knowledge. We already talked about making the agent self-aware of its limits is important. You want to build attribution systems, think about references, that clearly show which information sources influenced agent decisions. Remember that different users need different level of explanations. Executives need high-level strategic reasonings, operators need tactical decision factors, and developers need technical debugging information. Think about of all the different roles that access your AI agent and define what kind of transparency and explainability each of these roles needs. You want to create this explanation interfaces for each of these user roles and preferences, but you also want to maintain consistency with how reasoning is represented internally. Let's look at how the agent continuously learns and improves. Unlike traditional software that remains static after the deployment, AI agents have the potential to improve through interaction. But only if you actually design effective feedback loops that capture the learning opportunities and translate them into improved performance. Architecting a feedback loop isn't just about collecting user ratings. It's about creating a system that can identify improvement opportunities, capture the corrective input, validate the changes, and demonstrate the progress to the user. You can capture implicit feedback that comes from user actions, accepting or rejecting agent suggestions, modifying agent outputs, or choosing to escalate versus allowing autonomous operations. These signals provide valuable training data and doesn't require explicit user effort. On the other hand, you can have explicit feedback mechanism that should be contextual and lightweight. You want them to appear at natural interaction points rather than having a separate survey or rating. When the user corrects agent mistakes, the interface should confirm that the agent learned from the correction and apply the learning in similar situations. Sometimes there may also be approval processes of these new learnings in case that agent has wide impact across the organization. You want to design feedback aggregation systems that identify patterns also across users and use cases. You want to distinguish between things that are individual preferences versus universal improvements. Finally, you want to create a feedback visualization that shows the user how the input has improved the agent over time, reinforcing the value of their investment in training the system. This is crucial for a competitive advantage for your product. This transparency about learning and improvement builds trust and encourages continuous engagement with feedback mechanism. After you created the most sophisticated AI agent design, you really want to make sure it's useful. And it's going to be worthless if users cannot or will not integrate it into their existing workflows. Successful designs require an integration strategy that enhances, it doesn't replace the established process. You want to work within the existing technical constraints and respect the investment that organizations have made in their current systems. The goal is that you really want to create an integration pattern that feels natural and valuable rather than forced and disruptive to the existing status quo. The augmentation pattern it introduces agent capabilities as an enhancement to existing tools rather than a replacement. For instance, you want to add an AI research agent to an existing CRM system that can automatically gather prospect intelligence without changing the core sales workflow. The parallel pattern runs an agent alongside an existing process, allowing gradual transition and validation. Organizations can compare agent outputs with traditional approaches, building confidence before full cutover. The gateway pattern positions agents as intelligent interfaces to complex legacy systems, simplifying interactions without requiring system replacement. The federation pattern connects multiple existing systems through an agent that can then coordinate across them, creating new capabilities from existing investments. Each pattern has different implementation requirements, change management implications, and value delivery timelines. Choose the pattern based on the technical constraints, organizational readiness, and the specific value proposition of your agent capabilities. Let's talk now about multimodal. Multimodal capabilities in AI agents, they're not just different types of input and different types of outputs. They can fundamentally change how human and agents can collaborate. When an agent can process images and understand documents, generate visualizations, and coordinate across multiple information channels simultaneously, you can create entirely new interaction pattern. The key is designing these interfaces together so that they're integrated naturally rather than bolting them onto existing text-based patterns. Consider a quality control agent in manufacturing that contains visual inspection through cameras, sensor data analysis, and natural language reporting. The interface might show live video feeds with AI-generated annotation highlighting potential issues, friend visualizations that correlate visual defects with sensor readings, and natural language summaries that explain complex patterns in accessible terms. Users can intervene by clicking directly on video feeds to correct classifications, speaking natural language commands while pointing a specific visualization, or sketching patterns that they wanted the agent to watch for. This rich multi-channel interaction creates a more intuitive and powerful collaborations that any single mode interface can provide. The design challenge here is not just technical integration, but creating an experience that's coherent, where the different modalities complement rather than complicate each other. Architecture affects AI agent design, namely when to use and how to use edge processing and local intelligence. The Edge AI fundamentally changes the interface design possibilities by eliminating network latency, ensuring data privacy, and enabling operation in disconnected environments. Real-time responsiveness enables new interaction patterns that are impossible with cloud-based processing. This is required for manufacturing or offline support for in-store agents in retail. Privacy-preserving interfaces can, for instance, show sensitive data analysis without ever transmitting the underlying information. This is crucial for healthcare, financial, and sometimes personal applications. This is, however, a large topic, and we cannot fully explore it in a single slide. However, one thing we can do is to discuss the design constraints that edge processing adds. In general, when designing edge AI agents, you will have to take into account computational limitations. Models are not as powerful when they have to run on the edge, updating mechanisms of these models and of your agents in general, and capability boundaries that will not be escapable. Effective edge-based agent interfaces have to leverage the advantages and also manage the specific limitations. You can, however, think of hybrid systems. In that case, you can design clear capability boundaries that help user understand what the edge agent can do versus what actually requires cloud connectivity. This is important for transparency, especially when privacy concerns are there. You want to implement a graceful degradation where agents remain useful even when offline, and the capabilities are more limited. You also have to think of synchronization that clearly show when local and cloud knowledge diverge and provide control for selective updates. Sometimes this are things that can happen, and also design a feedback mechanism that can also operate locally but synchronize when connected. This ensures continuous improvement even without constant connectivity. We already saw how continuous learning and continuous improvement is fundamental to AI agents. You have to remember that edge processing isn't just like a technical architecture. It enables new user experiences and trust relationships that can become significant competitive advantages, especially in specific verticals. Testing AI agents present unique challenges compared to traditional software testing. Agent behavior are probabilistic rather than deterministic. They're not explicitly programmed, and they're context dependent rather than consistent. Your testing and validation approach must account for this fundamental unpredictability while still ensuring that agent meet quality standards and user expectations. This requires new testing methodologies, metrics, and tools that go beyond traditional QA processes. Behavioral testing frameworks should evaluate agent across a range of scenarios rather than checking for specific outputs. Create test suites that includes routine cases to ensure basic competence, edge cases to understand capability boundaries, adversarial cases to test robustness, and regression cases to ensure improvements don't degrade existing capabilities. It's very important to have a continuous evaluation system that monitors agent performance and production. You want to identify drift, degradation, and unexpected behaviors before they impact users. Design a human-in-the-loop validation process where domain expert will review agent decisions on a sampling basis, providing both quality assurance and training data. Develop confidence calibration metrics that ensure agents accurately assess their own uncertainty. We already talked about that when we were talking about escalation pathways and how agents has to be self-aware. Create explainability testing that verifies that agents can articulate their reasoning in ways that users can understand. You have to remember that testing is not just about finding failures, but understanding the conditions under where the agent performs well or poorly. This information should inform both the user guidance, which is usually accomplished in product with agent self-awareness, and also future improvements, so you know which parts of the agent experience you want to improve. Now that you have your agent and it's integrated in the user's workflow, how do you measure success? Traditional metrics like uptime and response time remain important for AI agents, but you really want to measure effective human-agent collaboration. So you need additional metrics. You want to capture a level of autonomy and delegation and gauge the progressive trust building. Your metrics should evaluate not just whether the agent works, but also how well it collaborates with humans and delivers value over time. We have three main areas of metrics that are specific to AI agents. The first one is about trust and autonomy. You want to track autonomy progression, how quickly users advance to trust levels, and what percentage of tasks eventually reach full autonomy. Intervention rates measure how often humans need to correct or override agent decisions, with trends showing whether the agent is learning effectively. The second area focuses on values and efficiency. Time to value measures how quickly new users become productive with the agent and how much efficiency gain they achieve over time. Escalation quality metrics evaluate whether escalations happen at appropriate times and provide useful context for human intervention. Finally, the third area is the one that we use to measure how well the agent can improve and continually learn. The explanation effectiveness metrics assess whether users understand and trust agent reasoning when they engage with the transparency features. Feedback loop velocity measures how quickly the user corrections translate into improved agent performance. This is really important to make sure that the agent is actually learning. In general, you want to design adoption curves that show not just usage rate, but the depth of engagement with agent capability. And you also want to create composite metrics that balance efficiency gains, so cost and time to market and value, with quality, maintenance, and user satisfaction. Aspects that affect agent design. We looked how you can create effective designs that build trust, handle complexity, and create sustainable competitive advantages. Your next step is applying these design principles to the specific opportunities you identified using the framework from our first session. Start by selecting your highest priority opportunity and work through each of the design dimensions we discussed today. Begin with interaction pattern selection based on your specific workflow requirements and user needs. Design your progressive trust building approach with clear stages and advancement criteria. Design your error handling and escalation pathways before you write any code. Plan your feedback loops and validation approaches as core design elements, not afterthoughts. Finally, create integration strategies that respect existing workflows while demonstrating clear value. Document your decisions and reasoning behind them, as this will guide your development team and help maintain design coherence as the project evolves. Thanks for listening to the whole session. If you have found this interesting, you may want to listen to the next webinar as well, where we'll explore how to manage the implementation of these designs through the unique challenges of AI agent development projects. We'll discuss adapted agile methodologies, cross-functional team coordination, quality frameworks, and the practical realities of building systems with inherent uncertainty. Thank you for your time, and I look forward to continuing this journey with you in our next session. Feel free to reach out to me through LinkedIn.